This video in the Pure Maths course on algebra is on the laws of logarithms. Now, the previous videos on indices, in the previous videos we saw these three rules. A to the power of p times a to the power of q is equal to a to the p plus q. So you add the indices when you multiply. A to the p divided by a to the q is a to the p minus q, so we subtract the indices when you divide, and a to the p raised to the power of a number n is equal to a to the np, so we can multiply the indices together when we raise to the power. Also, in the previous video on introduction to logarithms, we found that if x is a to the power of p, we could also write that as p is the log of x to the base a. So that's another way of writing x equals a to the power of p. If we have another number y equal a to the power of q, we could by the same way write that as q is the log of y to base a. Now, if we multiply x by y, xy, that's the same as multiplying a to the power of p times a to the power of q, and by the rules of indices we can add the indices, so that is equal to a to the p plus q. So we have xy is a to the p plus q, and in the same way that x is a plus a to the power of p can be written as p is log of x to base a, we can write p plus q, the thing that's in the index, in the power, is equal to log of this side here, xy, to the base a, in the same way. But p and q are log x and log y, so therefore we have log x to base a plus log y to base a is equal to log of xy to base a. And this is the addition rule of logarithms. So if we add the logarithms of two numbers to the same base, it's equivalent to the log of the product of the two numbers, x and y. The addition rule of logarithms. Now, in a similar way, we can write x divided by y as a to the power of p divided by a to the power of q. Because x is a to the power of p and y is a to the power of q. Or we could write it as a to the p divided by a to the q, like that, and use the subtraction rule in indices to write that as a to the p minus q. So x divided by y is a to the p minus q, and this can be written in the logarithm form as p minus q is the log of x divided by y to base a, and as p is log x and as q is log y, both to base a, we have log of x minus log y is log x divided by y, and that is the subtraction rule of logarithms. Thirdly, if we have x equals a to the power of p, if I raise x to the power of n, I have x to the power of n is a to the power of p all to the power of n, which of course by the multiplication rule of indices is a to the pn, or a to the np. So we have x to the n is a to the np, and in logarithmic form log of x to the n to base a is equal to np, and p is of course log x, so that is n log x to base a. So this gives us a third rule, log of x to the n is n log x. to the same base. So here are the three rules. Log x plus log y is log xy, log x minus log y is log x over y, and log x to the n is n log x. So if we want to combine these two, log 3 to base 2 plus log 4 to base 2, using the first rule there, that would be log of 3 times 4 to base 2, so that's log 12 to base 2. Log 35 to base 3 minus log 7 to base 3 is equal to log 35 divided by 7 to base 3 by the second rule, the subtraction rule, so that would be log of 5 to base 3, 35 divided by 7. Log of 3 to the power 5 to base 2 by the third rule, log of x to the n is n log x, that is 5 log 3 to base 2. A special case of the third rule, which is very useful, if we have log x to the power minus 1, well, log x to the n is n log x, so that would be the same as minus 1 times log x. This is true of any base. I'll put in base a there. So log x, x to the power minus 1 of course is 1 over x, so we have log of 1 over x to base a is minus log x, and that's a very useful rule. Now some examples. Here's the first one of using all the rules in combination. 4 log 3 plus 2 log 5. Here are the rules here. Well, we can't add these directly. We can't use the top one directly because this is log plus log is equal to log of the product xy. We've got 4 log plus 2 log. So what we have to do is use the third rule in reverse. 4 log 3 is equal to log 3 to the power of 4 to base 2, and 2 log 5 is log 5 to the power of 2 to base 2. Well, 3 to the power of 4 is 81, and 5 to the power of 2 is 25. And now we can use the first rule, the addition. Log of 81 plus the log of 25 is the log of 81 times 25, which is the log of 2025. Now we can use these laws involving algebraic expressions. Let's see how we might express this log a b cubed c squared in terms of just log a, log b, log c. Well, there's three things here. By the addition rule, this would be log a plus log b cubed plus log c cubed, which is equal to log a, and then by the third rule, the power rule, log b cubed is 3 log b, and log c cubed, c squared, that should be, log c squared is 2 log c. And the second one here, 2 log a root 3 over b root c. Well, the 2 in front becomes log of a root 3 over b root c squared by the power rule. And if we square those, that would be a squared times root 3 squared, which is 3. And we've got b squared times c, root c squared. By the subtraction rule, this would be log of 3a squared minus, that should be b squared of course there, log b squared c. By the addition rule, log 3a squared would be log 3 plus log a squared, and by the addition rule there we have minus log b squared minus log c. And then by the power rule again, we've got log 3 plus, and log a squared is 2 log a, minus log b squared, which is 2 log b, and minus minus, so plus log c, like that. Note that I didn't put a base in any of these. If we don't put a base, then it's true for any base, so it just means any base. Note also that if we don't have the same base, so log 5 to base 2 plus log 7 to base 3, that cannot be simplified. You can only have do the simplification when we have the same base, so 2 there and 2 there, we could write as log 35, but not in this case. Now, pause the video and solve the following problems. Okay, A, we've got log 9 to base A minus log 1/3 to base A. Well, log 9 to base A, 1/3, of course, is, we can write that as 3 to the power of minus 1, so that's log of 3 to the power of minus 1, and so we can write this as log 9 to base A, and then using the power rule, write that as minus minus or plus log 3 to base A, and then we can multiply, use the addition rule, and we'll be able to multiply 9 and 3, so that is log of 9 times 3 is log 27 to base A. B, a half log 25 plus 2 log 3. We're using the power rule on both of those logs. A half log 25 is log 25 to the half, and 2 log 3 is log 3 squared, and so to the power of a half, of course, means the square root, so we have the square root of 25 is 5, so that's log 5 plus log 3 squared, which is log 9, and we're using the addition rule. We can multiply 5 and 9 to make log of 5 nines of 45. Number 2, express in the form p log x to base q. These two expressions, 4 log, this is part A, 4 log 1 over root x to base q. Well, of course, 1 over the square root of x we could write as x to the power of minus a half. And then we can write that as the log, using the power rule, of x to the power of minus a half to the power of 4, which is log of x to the power of minus 2, using the product rule for indices, and again using the power rule for logarithms, that's minus 2 log x to base q. Part B, using the power rule on each of those, we'd have 3 log x squared would be log x squared cubed, and minus a half log x to the power of 4 to the power of a half. The power rule for indices would give x to the power of 6, log x to the power of 6, that half wouldn't be there, of course, minus log of x squared, and the subtraction rule for logarithms would be log of x to the power of 6 divided by x squared, and we subtract the indices, that would be log of x to the power of 4. And using the power rule for logarithms in reverse again, that will be 4 log x to base q. Number 3, evaluate these two expressions without using a calculator. So part A, we have both these logarithms to the power are to the base of 3. So using the subtraction rule, that would be log of 54 divided by 2 to base 3, or log of 27 to base 3. And 27 we know is 3 cubed, so that would be log of 3 cubed to base 3, which by the power rule would be 3 log 3 to base 3. And log of 3 to base 3, the log of any number to its same base is 1, so that is just 3. Part B, the first expression here, third log 64, by the power rule is log of 64 to the power of the third, and the second part is log of 25 squared. Of course, that is equal to log to base 4 of 64 cube root of 64 is 4, plus log of, and I could write this as 25 squared, that is 5 squared, or 5 to the power of 4. So log of 4 to the power of 4 is just 1. Log of 5 to the power of 4 to the base of 5 is 4. That would be the same as 4 log 5 to base 5, which of course would be 1. So 4 log 5 to base 5 is just 4. So that comes to 5. The fourth group of problems here, express in the form p log a plus q log b. First of all, we've got log ab to the 7. Using the addition rule, we would write that as log a plus log b to the power of 7, and then using the power rule on the second term there, log a plus 7 log b. The second part, log a root b, we'd write that as log a plus log root b using the addition rule, and then as the square root is of course log, the square root would be b to the power of a half, so we have log a plus log b to the power of a half, and that is log a plus a half log b. And then part C, log of the square root of something is of course the log of a cubed b to the power of 5 to the power of a half, and using the power rule that becomes a half log a cubed b to the power of 5, which would be a half of log of a cubed plus log b to the power of 5 by the addition rule, and then we can write that is a half of log 3 log a plus 5 log b, which, expanding the bracket, is 3 over 2 log a plus 5 over 2 log b. So that's the end of the this video on the laws of logarithms. So now you can return to Study Smart and do the next video.